Good morning, children. Today we are going to have a discussion on combination of capacitors. So we know what are capacitors. Capacitors are those devices which store charges and they store energy in form of electrical plate in between the plates. ಹೌದಲ್ವಾ ಮಕ್ಕಳ? ಸೊ ಕೆಪಾಸಿಟರ್ ಒಂದು ಡಿವೈಸ್, ಅದು ಚಾರ್ಜನ್ನು ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ. ಅವೆರಡರ ಪ್ಲೇಟ್ಗಳ ಮಧ್ಯೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರೋದ್ರಿಂದ ಅಲ್ಲಿ ಎನರ್ಜಿ ಕೂಡ ಸ್ಟೋರ್ ಆಗಿರುತ್ತೆ. Am I clear with this? Okay, now, sir, why do we need combination of capacitors? Look here. For that instant, I will consider a capacitor of 2 microfarad. Okay? Look here. So we have a capacitor whose capacitance is 2 microfarad. And we have another capacitor of capacitance, let me take that as 5 microfarad, and another capacitor, some 3 microfarad. Now I have 3 capacitors. One is 2 microfarad and another is of 5 microfarad capacitance and another is 3 microfarad capacitance. Now for a circuit, if I need a capacitance whose value is less than 2 microfarad. ಈಗ 3 ಕೆಪಾಸಿಟರ್ಸ್ ಇದೆ, ಬಟ್ ನನಗೆ ಯಾವುದೋ ಒಂದು ಡಿವೈಸಿಗೆ ಒಂದು ಕೆಪಾಸಿಟನ್ಸ್ ಬೇಕು, ಆ ಕೆಪಾಸಿಟನ್ಸ್ 2ಗಿಂತ ಕಮ್ಮಿ ಇತ್ತು ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. ಆಗ ನಾವು ಯಾವ ಥರ ಯೂಸ್ ಮಾಡ್ಬೋದು ಈ ಕೆಪಾಸಿಟರ್ಸ್ನ? 2ಗಿಂತ ಕಮ್ಮಿ ಬೇಕು, ಸೊ ಬರೀ 2 ಯೂಸ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಸೊ ಹಾಗಾದ್ರೆ ಏನು ಮಾಡೋಣ? ಲುಕ್ ಹಿಯರ್, ಇಫ್ ಐ ಕನೆಕ್ಟ್ ದಿಸ್ ಕೆಪಾಸಿಟರ್ಸ್ ಇನ್ ದಿಸ್ ಮ್ಯಾನರ್, one end of the capacitor connected to another end of the capacitor, end to end connection ಅನ್ನು ಕೊಟ್ಟು ನಾನು 2 microfarad, 5 microfarad and 3 microfarad ಕೆಪಾಸಿಟರ್ಸ್ನ ಈ ಥರ ಕನೆಕ್ಟ್ ಮಾಡಿದರೆ ಇವುಗಳ ಓವರ್ ಆಲ್ ಕೆಪಾಸಿಟೆನ್ಸ್ 2 microfaradಗಿಂತ ಕಮ್ಮಿ ಬರುತ್ತೆ. ಸೊ ಸರ್ ಹಾಗಾದರೆ ಯಾವ ಟೈಪ್ ಕನೆಕ್ಷನ್ ಮಾಡಿದ್ದೀರಾ? ಸೀರೀಸ್ ಕನೆಕ್ಷನ್ ಮಾಡಿದ್ದೀವಿ. ಸೀರೀಸ್ ಕನೆಕ್ಷನ್ ಮಾಡಿದರೆ ನಮ್ಮ ಹತ್ರ ಇರೋ 3 ಕೆಪಾಸಿಟೆನ್ಸ್ಗಿಂತ ಕಡಿಮೆ ಕೆಪಾಸಿಟೆನ್ಸನ್ನು ಎಸ್ಟಾಬ್ಲಿಷ್ ಮಾಡ್ಬೋದು. ಓಕೆ, ಸೊ ಇನ್ ಸಮ್ ಅನದರ್ ಕೇಸ್, ಓಕೆ, ಐ ವಿಲ್ ಟೇಕ್ ಅನದರ್ ಕೇಸ್ ವೇರ್ ಐ ಹ್ಯಾವ್ ಸೇಮ್ ಕೆಪಾಸಿಟರ್ಸ್ 2 microfarad, 5 microfarad and 3 microfarad capacitors. So we have got 3 capacitors here, but for a circuit I need a capacitance whose value is more than 5, even 7 or 8. Sir, how can we establish by using these 3 capacitors? We can do it by making them connect in this format. This is a 2 microfarad capacitor and this is a 5 microfarad capacitor and this is 3 microfarad capacitors. We will connect them like this. All the capacitors are connected between 2 points. Let me take this as P and this as Q. One end of each capacitor is connected to P. Another end of each capacitor is connected to Q. If we establish this kind of combination of capacitors, generally we call it as parallel capacitors, which we will study in details. Okay, in the next topic. So ಈ ಥರ ನಾನು ಕನೆಕ್ಟ್ ಮಾಡಿದರೆ I will get the capacitance which is more than 5. So why are we using combination of capacitors? ನಮ್ಮ ಹತ್ರ ಒಂದು 2-3 capacitors ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ, more number of capacitors, okay, but to get the desired value of capacitance, 1 microfarad capacitance ಇದೆ, 2 microfarad ಇದೆ, 3 microfarad ಇದೆ, ಬಟ್ ನನಗೆ 0.5 microfarad ಕೆಪಾಸಿಟನ್ಸ್ ಬೇಕು. ಏನು ಮಾಡೋಣ? ಇದೇ ಕೆಪಾಸಿಟರ್ಸ್ಗಳನ್ನ ಡಿಫ್ರೆಂಟ್ ಕಾಂಬಿನೇಷನಲ್ಲಿ ನಾವು ಕನೆಕ್ಟ್ ಮಾಡಿದರೆ ಅವುಗಳ ಓವರ್ ಆಲ್ ಕೆಪಾಸಿಟನ್ಸನ್ನು ನಾವು ಕಮ್ಮಿ ಕೂಡ ಮಾಡ್ಬೋದು, ಜಾಸ್ತಿ ಕೂಡ ಮಾಡ್ಬೋದು. Am I clear with this? Sir, why do we need combination of capacitors? Sir, we can take capacitors, we can connect them in different combination and we can get different capacitance. ಕಮ್ಮಿ ಕೂಡ ಮಾಡ್ಬೋದು ಓವರ್ ಆಲ್ ಕೆಪಾಸಿಟನ್ಸ್ನ, ಜಾಸ್ತಿ ಕೂಡ ಮಾಡ್ಬೋದು. Am I clear with this concept? Okay, now we have mainly two types of combination, 2 types of combinations, 2 types of combination. Okay, so one is series combination of capacitors, where we connect capacitors in this format. This is capacitor 1, capacitor 2, capacitor 3. Look here, capacitors are connected with each other. Look here, this capacitance, this end of the capacitance is connected with this end, and this end of the capacitor is connected with this end of the capacitors. So this is a series combination. Similarly, we have another combination, parallel combination of capacitors, where capacitors are connected between two common points. Okay, so this is C1, this is C2, this is C3, and this is the point, let me take this point as P and this point as Q. Look here, one end of C1, C2, C3 connected to P, another end of C1, C2, C3 connected to Q. This is called parallel combination. And we have another combination which we called as mixed combination, where like this is a capacitor 1, capacitor 2. See, these are connected in series with each other, and another capacitor connected parallel to these two capacitors. So what do you call this? Mixed capacitor combination. Am I clear with this? Okay, so now, we are clear why we use combination of capacitors to get the desired capacitance. ಸೊ 3 ಕೆಪಾಸಿಟರ್ಸ್ ಇದೆ, ನಾವು ಮನ್ಸು ಮಾಡಿದರೆ ಅದನ್ನು ಡಿಫ್ರೆಂಟ್ ಕಾಂಬಿನೇಷನ್ ಮಾಡಿ ಅತ್ಯಂತ ಕಮ್ಮಿ ಕೆಪಾಸಿಟೆನ್ಸ್ ಬೇಕಾದ್ರೂ ಎಸ್ಟಾಬ್ಲಿಷ್ ಮಾಡ್ಬೋದು, ಜಾಸ್ತಿ ಕೆಪಾಸಿಟೆನ್ಸ್ ಬೇಕಾದರೂ ಎಸ್ಟಾಬ್ಲಿಷ್ ಮಾಡ್ಬೋದು. ವಿ ಹ್ಯಾವ್ 3 ಟೈಪ್ಸ್ ಆಫ್ ಕಾಂಬಿನೇಷನ್. ಒನ್ ಇಸ್ ಸೀರೀಸ್, ಅನದರ್ ಒನ್ ಇಸ್ ಪ್ಯಾರಲಲ್, ಆ್ಯಂಡ್ ಅನದರ್ ಒನ್ ಇಸ್ ಮಿಕ್ಸ್ಡ್. ಓಕೆ, ಸೀರೀಸ್ ಕನೆಕ್ಷನ್ ಅಂತ ನಾವು ಎಕ್ಸಾಕ್ಟಾಗಿ ಯಾವ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ಮೇಲೆ ಡಿಸೈಡ್ ಮಾಡ್ತೀವಿ, ಪ್ಯಾರಲಲ್ ಅಂತ ಹೇಗೆ ಡಿಸೈಡ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದನ್ನು ನಾವು ನೆಕ್ಸ್ಟ್ ಟಾಪಿಕಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಓಕೆ children, after discussing series, parallel and mixed combination, I want you to understand what is equivalent capacitance. This is a very important parameter. I want you to understand this. If you understand this, and parallel combination, equivalence in parallel combination, equivalence in series combinations becomes very easy. Look here. Before I step on to the equivalence capacitance, I want you to understand. Look here. This is the capacitor. Let me take this capacitor as C, okay, and this is connected to a battery, and this is the positive terminal, this is the negative terminal. Positive terminal is considered as higher potential, negative terminal is considered as lower potential. Okay, now when we connect the battery, what happens? The plate which is connected to positive terminal will get positively charged. The plate which is connected to negative terminal will get negative charges. This battery will keep charging capacitance up to a point where potential across the capacitor and potential across the battery becomes equal. So battery ಎಲ್ಲಿ ತನಕ ಚಾರ್ಜ್ ಮಾಡುತ್ತೆ ಕೆಪಾಸಿಟರ್ನ, ಯಾವಾಗ ಕೆಪಾಸಿಟರ್ಸ್ ಅಕ್ರಾಸ್ ಇರೋವಂಥ ವೋಲ್ಟೇಜ್ ಬ್ಯಾಟ್ರಿ ವೋಲ್ಟೇಜ್ಗೆ ಈಕ್ವಲ್ ಆಗುತ್ತೋ ಅಲ್ಲಿ ತನಕ ಸ್ಟೋರ್ ಆಗುತ್ತೆ. ಸೊ ಈಕ್ವಲ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಚಾರ್ಜಸ್ ಎಕ್ಸ್ಟ್ರಾ ಸ್ಟೋರ್ ಆಗಲ್ಲ. ಐ ಕ್ಲಿಯರ್ ವಿತ್ ದಿಸ್? ದಿಸ್ ಇಸ್ ಅನ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್. ಆ್ಯಂಡ್ ದಿಸ್ capacitor stores charge that is equal to Q. Let's assume that Q is equal to what? C into V. That means if we know the capacitance of this capacitor and voltage across the capacitor, we can easily calculate charge. Look here, pay attention to this. These are the plates of capacitors. This is charged with positive charge, this is charged with negative charge. So this is positive, this is negative. So in between them electric field will exist. Direction of electric field is from what? Positive charge to negative charge, positive to negative. Look here, charge started accumulating, electric field started establishing. ಓಕೆ, ಸೊ ಚಾರ್ಜ್ ಬರ್ತಾ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಸ್ಟಾರ್ಟ್ ಆಯಿತು. ಸೊ ಚಾರ್ಜ್ ಸ್ಟೋರ್ ಆಗಬೇಕಾದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎಸ್ಟಾಬ್ಲಿಷ್ ಆಗಿದೆ. ದಟ್ ಮೀನ್ಸ್ ಇನ್ ಬಿಟ್ವೀನ್ ದ ಪ್ಲೇಟ್ಸ್ ಎನರ್ಜಿ ಈಸ್ ಸ್ಟೋರ್ಡ್ ಇನ್ ಫಾರ್ಮ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಓಕೆ, ಸೊ ನಮಗೆ ಎನರ್ಜಿ ಸ್ಟೋರ್ ಆಗಿದೆ ಅಂತ ಗೊತ್ತು. ಹೌ ಮಚ್ ಎನರ್ಜಿ ಈಸ್ ಸ್ಟೋರ್ಡ್ ಇನ್ ದ ಕೆಪಾಸಿಟರ್ಸ್? U is equal to half CV square. That means if I know the capacitance of the capacitor and the voltage across the capacitor, I can easily calculate how much energy is stored in capacitors. Am I clear with this concept? Okay, now look here once again. We connect the battery to the capacitors. What happens? The battery charges capacitors. Okay, so charge will be accumulated on each plate. One plate gets positive charge, another plate gets negative charge. In between the plates there will be electric field. Okay, in capacitor charges will store and energy will be stored, and these are its formulas. If we know capacitance, voltage, we can easily calculate charge, we can easily calculate energy. ಈ ಫಾರ್ಮುಲಾ ನಿಮ್ಗೆ ಇನ್ನೂ ಡಿರೈವ್ ಮಾಡಿಲ್ಲ, ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಇದನ್ನು ಡಿರೈವ್ ಮಾಡೋಣ ಮಕ್ಕಳ. ಓಕೆ, now imagine I have a circuit where capacitors are connected like this. These are the combination of capacitors, and then we will connect them to a battery. So we have connected them to a battery whose potential difference is V. Now imagine if I want to calculate how much charge is given to the combination of capacitors. I need a formula, Q is equal to C into V. Here which capacitance should I put? C1. ಬರೀ C1 ಹಾಕಿದ್ರೆ C1 C2 C3 ಕನ್ಸಿಡರ್ ಮಾಡಿದೀವ? ಇಲ್ಲ, ಹಾಗಾದರೆ ತಪ್ಪಾಗುತ್ತೆ. ಹಾಗಾದ್ರೆ C2 ಹಾಕೋಣ? ನೋ, I must put a capacitance which is provided by entire capacitors. All this combination I should put C provided by, that is the capacitance provided by entire combination C1 C2 C3. ಈ ಕಾಂಬಿನೇಷನ್ ಕನೆಕ್ಟ್ ಆದಾಗ ಎಷ್ಟು ಕೆಪಾಸಿಟನ್ಸ್ ಕೊಡುತ್ತೆ ಆ ಕೆಪಾಸಿಟನ್ಸ್ನ ಕಂಡುಹಿಡಿದ್ರೆ ನಾನಿಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಬೋದು. ದ ಸೇಮ್ ಗೋಸ್ ವಿತ್ ಹಿಯರ್. U is equal to half CV square ಇದೆ. ಇಲ್ಲಿ ನಾನು ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್ ಇನ್ ದಿಸ್ ಕೆಪಾಸಿಟರ್ಸ್, ಐ ನೀಡ್ ಟು ಫೈಂಡ್ ದಿಸ್ ಔಟ್. ಬಟ್ ವಿಚ್ C should I present here? I cannot present C alone or C2 alone or C3 alone. ಒಂದೊಂದೇ ಹಾಕೋಕ್ಕಾಗಲ್ಲ, ಯಾಕೆಂದರೆ ಅದು ಡಿಫ್ರೆಂಟ್ ಕಾಂಬಿನೇಷನಲ್ಲಿದೆ. ಕಾಂಬಿನೇಷನ್ ಬೇರೆ ಆದರೆ ಅದರಲ್ಲಿ ಸ್ಟೋರ್ ಆಗೋ ಚಾರ್ಜಸ್ ಕೂಡ ಸ್ಟೋರ್ ಆಗುತ್ತೆ, ಕೆಪಾಸಿಟನ್ಸ್ ಕೂಡ ಸ್ಟೋರ್ ಆಗುತ್ತೆ, ಚೇಂಜ್ ಆಗುತ್ತೆ. ಸೊ ನಾವು I need a common C which represents the capacitance provided by all of this. So what I am going to do is, look here, this I am going to take same battery, okay, same potential, and same amount of charges is given to the capacitor. This I will call this capacitance as C. Now this capacitance accept the same charge as accepted by these three. C1 C2 C3 ಎಷ್ಟು ಚಾರ್ಜನ್ನು ಕನ್ಸ್ಯೂಮ್ ಮಾಡ್ತಾ ಇದೆಯೋ ಅಷ್ಟೇ ಚಾರ್ಜನ್ನು ಈ ಸಿ ಕೆಪಾಸಿಟರ್ ಕೂಡ ಕನ್ಸ್ಯೂಮ್ ಮಾಡಿದೆ. ಓಕೆ, ದ ಅಮೌಂಟ್ ಆಫ್ ವೋಲ್ಟೇಜ್ ಗಿವನ್ ಟು ದೀಸ್ ತ್ರೀ ಕೆಪಾಸಿಟರ್ಸ್ ಇಸ್ ಗಿವನ್ ಟು ದೀಸ್ ಕೆಪಾಸಿಟರ್. ಸೊ ಚಾರ್ಜಸ್ ಸೇಮ್ ಕೊಟ್ಟಿದ್ದೀವಿ ಕೆಪಾಸಿಟರ್ಗೆ, ವೋಲ್ಟೇಜ್ ಸೇಮ್ ಅಪ್ಲೈ ಮಾಡಿದ್ದೀವಿ. ಸೊ ಹಾಗಾದರೆ ಇಲ್ಲಿ ಬರೋ ಕೆಪಾಸಿಟನ್ಸ್ ಇವು ಮೂರು ಬರೋ ಕೆಪಾಸಿಟನ್ಸ್ಗೆ ಏನಿರುತ್ತೆ? ಈಕ್ವಲ್ ಇರುತ್ತೆ. ಸೊ ಐ ಕ್ಯಾನ್ ಸೇ ಸಿ ಈಸ್ equivalent to combination of C1 C2 and C3 as shown in the figure. ಈ ಫಿಗರಲ್ಲಿ C1 C2 C3 ಎಷ್ಟು ಕೆಪಾಸಿಟನ್ಸ್ ಪ್ರೊವೈಡ್ ಮಾಡ್ತಿದೆಯೋ ಈ ಕೆಪಾಸಿಟರ್ ಕೂಡ ಅಷ್ಟೇ ಕೆಪಾಸಿಟನ್ಸ್ ಪ್ರೊವೈಡ್ ಮಾಡ್ತಿದೆ. ಸರ್ ಈ ಕೆಪಾಸಿಟರ್ ನಾವು ಇನ್ಸರ್ಟ್ ಮಾಡೋದ? ನೋ, ದಿಸ್ ಇಸ್ ಎನ್ ಇಮ್ಯಾಜಿನರಿ capacitor which consumes equal amount of charge as this circuit, which is supported across same potential difference. That means if I can find out the relation between equivalent capacitor and combination of capacitor, we can easily calculate charge on the capacitors or charge on the combination of capacitors and energy stored in the combination of capacitors. ನೋಡಿ ಇನ್ನೊಂದ್ಸರಿ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಮಕ್ಕಳ, ಈಕ್ವಿವೆಲೆಂಟ್ ಕೆಪಾಸಿಟನ್ಸ್ ಅಂದರೆ ಏನಂದರೆ ನೋಡಿ ಮಕ್ಕಳ, C1 C2 C3 ಈ ಥರ ಡಿಫ್ರೆಂಟ್ ಕಾಂಬಿನೇಷನಲ್ಲಿ ಇರುತ್ತೆ. ಈ ಕಾಂಬಿನೇಷನಲ್ಲಿ ಇದ್ದಾಗ ಇದಕ್ಕೆ ಟೋಟಲ್ ಚಾರ್ಜ್ ಎಷ್ಟು ಕೊಟ್ವಿ, ಇಲ್ಲಿ ಎಷ್ಟು ಕೆಪಾಸಿಟನ್ಸ್ ಇದೆ ಅಂತ ಕಂಡುಹಿಡಿಯೋದು ಕಷ್ಟ ಆಗ್ತದೆ. ಸೊ ನಮಗೆ ಕೆಪಾಸಿಟನ್ಸ್ ಮತ್ತು ವೋಲ್ಟೇಜ್ ಬಂದರೆ ವಿ ಕ್ಯಾನ್ ಈಸಿಲಿ ಫೈಂಡ್ ಔಟ್ ಎನರ್ಜಿ. ಫಾರ್ ದ್ಯಾಟ್ ಪರ್ಪಸ್ ವಾಟ್ ವಿ ಡೂ ಈಸ್ ವಿ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ದ ಸೇಮ್ ಸರ್ಕ್ಯೂಟ್, same amount of charge is being given to this capacitor, same voltage is being applied across this capacitor. ಚಾರ್ಜ್ ಮತ್ತು ವೋಲ್ಟೇಜ್ ಸೇಮ್ ಇದೆ ಅಂದರೆ ಕೆಪಾಸಿಟನ್ಸ್ ಏನಾಗುತ್ತೆ? ಸೇಮ್ ಇರಲೇಬೇಕು. ಹಾಗಾದರೆ ಈ ಕೆಪಾಸಿಟರ್ ಇದೆಯಲ್ಲ, ಇದು ಕೆಪಾಸಿಟನ್ಸ್ ಎಷ್ಟಿದೆ? ದಿಸ್ ಇಸ್ ಈಕ್ವಿವೆಲೆಂಟ್ ಟು ದೀಸ್ ತ್ರೀ. ಸರ್ ವೈ ನಾಟ್ ದೇ ಆರ್ ಈಕ್ವಲ್, ವೈ ನಾಟ್ ಇಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು C1 C2 C3? ಇಟ್ ಈಸ್ ನಾಟ್ ಈಕ್ವಲ್, ದಿಸ್ ಈಸ್ ಈಕ್ವಿವೇಲೆಂಟ್. ಅಂದರೆ ಈ ಮೂರು ಕೆಪಾಸಿಟರ್ ಈ ಕಾಂಬಿನೇಷನಲ್ಲಿ ಸೇರಿ ಎಷ್ಟು ಕೆಪಾಸಿಟನ್ಸ್ ಕೊಡುತ್ತೋ ಇದು ಅಷ್ಟೇ ಕೆಪಾಸಿಟನ್ಸ್ ಕೊಡುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ ಫಂಕ್ಷನ್ ಆಫ್ ಸಿ ಆ್ಯಂಡ್ ಸಿ ಈಸ್ ಈಕ್ವಲ್ ಟು C1 C2 C3 ಇನ್ ದಿಸ್ combination. Am I clear with this? Thank you. Children, here we are going to discuss about series combination of capacitors. What are the important parameters that decides it is a series combination? Okay, see, these are the capacitors C1, C2 and C3. They are connected in series with each other. Okay, now this terminal of the battery is positively charged and this terminal is negatively charged, and this is higher potential. Positive terminal is taken as higher potential and negative is taken as lower potential. Sir, why do we consider like this? Always remember, if you remember this becomes very easy. Look here, this is the battery. Okay, this is positive terminal, this is negative terminal. Look here, if I have an electric field here, this is the electric field. Okay, this is the electric field. If I place a charge, if I place this charge, unit positive charge here, and we will let it free. What happens? The unit positive charge will start moving in the direction of electric field. Now on the unit positive charge, the electric field it starts moving along the direction of electric field. Am I clear with this? Okay, so and this positive charge, we consider it has moved from higher potential to lower potential. Am I clear with this concept? So charge higher potential in the lower potential. Test charge now yavaglu yavadanu consider martivi? Unit positive charge. For that instant, this is a positive terminal and this is the negative terminal and this is the test charge. If I place the test charge, where will it go? It will move away from the positive charge, because this positive plate will repel positive and this negative will attract, so it will start moving in this direction. That means charge moves in this direction, means this is considered as higher potential, this is considered as lower potential. In between the capacitor plates, this is positive, this is negative. Okay, if we go in this direction, we will have potential drop. Okay, positive terminal in the negative terminal potential drop. Am I clear with this? Remember this, and this derivation becomes very easy. Now look here, we have connected capacitors. What will happen? This plate of capacitor C1, this plate is connected with positive terminal, so this will be charged, with the charge plus Q. Charges ಯಾವ ಥರ ಸ್ಟೋರ್ ಆಗುತ್ತೆ, ಇದನ್ನು ನಾನು ಪ್ಯಾರಲಲ್ ಪ್ಲೇಟ್ ಕೆಪಾಸಿಟರ್ಸ್ ಮುಂಚೆ ಇದ್ರ ಬಗ್ಗೆ ಅನಾಲಜಿ ಹೇಳಿದ್ದೀನಿ. ಕೆಪಾಸಿಟರ್ಸ್ನ ಬ್ಯಾಟ್ರಿ ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ ಯಾವ ಥರ ಚಾರ್ಜ್ ಆಗುತ್ತೆ ಅಂತ. ಸೊ ಅದರ ಕನ್ಕ್ಲೂಷನ್ ಏನು? ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಕನೆಕ್ಟ್ ಆಗೋದು ಪಾಸಿಟಿವ್ ಆಗಿ ಚಾರ್ಜ್ ಆಗುತ್ತೆ, ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ ಕನೆಕ್ಟ್ ಆಗೋದು ನೆಗೆಟಿವ್ ಆಗಿ ಚಾರ್ಜ್ ಆಗುತ್ತೆ. ಹೇಗೆ ಚಾರ್ಜ್ ಆಗುತ್ತೆ ಅದ್ರ ಬಗ್ಗೆ ನೀವು ಡೀಟೇಲ್ಸ್ ಬೇಕು ಅಂದರೆ ಪ್ಯಾರಲಲ್ ಪ್ಲೇಟ್ ಕೆಪಾಸಿಟರ್ಸಲ್ಲಿ ಸ್ಟಾರ್ಟಿಂಗಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀನಿ. ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಎ ಲುಕ್ ಎಟ್ ದಟ್. ಲುಕ್ ಹಿಯರ್, these positive charges will attract negative charges here onto this plate. Negative charges will be induced. ಎಷ್ಟು ಪಾಸಿಟಿವ್ ಇದೆಯೋ ಇಲ್ಲಿ ಅಷ್ಟೇ ನೆಗೆಟಿವ್ ಸ್ಟೋರ್ ಆಗುತ್ತೆ. ಈ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಎಲ್ಲಿಂದ ಬಂತು? ಈ ಪ್ಲೇಟಿಂದಲೇ ಬರಬೇಕು. ಈ ಪ್ಲೇಟ್ ಮತ್ತು ಈ ಕಂಡಕ್ಟರಿಂದ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಇಲ್ಲಿಗೆ ಬಂತು. ಇಲ್ಲಿದ್ದಂಥ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಎಲ್ಲ ಇಲ್ಲಿಗೆ ಬಂದಿದೆ. ಸೊ ವಾಟ್ ಈಸ್ ಲೆಫ್ಟ್ ಹಿಯರ್? ಪ್ಲಸ್ ಕ್ಯೂ. ಇಫ್ ದಿಸ್ ಬಿಕಮ್ಸ್ ಪ್ಲಸ್ ಕ್ಯೂ, ದಿಸ್ ವಿಲ್ ಅಟ್ರಾಕ್ಟ್ ಆಲ್ ದ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ from this branch. Okay, so this will get minus Q. So here from this plate, electrons move to this plate, so this plate gets positively charged, and negative terminal is connected to this plate, so this will get minus Q. Am I clear with this? Look here, in the series combination what happens? The battery charges these plates. The positive plate connected with the positive terminal gets the positive charge, and it induces equal amount of negative charge in the opposite plate. Okay, so and these charges come from this plate, so negative charges moves to this side, means this is left with positive charge. If this has positive charge, then this will induce negative charge here, and all these negative charges that come from this plate, so this is charged positively. So take a look at this. All the plates of the capacitors has equal magnitude of charges. Am I clear with this? Nodi neatag nodi makla. All the plates have equal magnitude of charge. Idralli estiде plus Q, idralli estide minus Q. Terminology different irbodu. Amount of charge estide Q, and every plate has got equal charge. Every capacitor has got equal charge. Okay. And what is the direction of conventional current? Positive terminal towards negative terminal. Okay. And another important thing, look here, the current flows for very small time. Within the small time, these capacitors get charged. So first important thing I am writing here, equal amount. ಹೌದಾ, ಬರಿಬೋದಾ ಮಕ್ಕಳ ನಾವು ಇದನ್ನು? ಈಕ್ವಲ್ ಅಮೌಂಟ್ ಆಫ್ ಚಾರ್ಜಸ್ ಆರ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ಅಕ್ರಾಸ್ ದಿ ಕೆಪಾಸಿಟರ್ಸ್. ಈಕ್ವಲ್ ಅಮೌಂಟ್ ಆಫ್ charges are distributed across capacitors in series combination. Okay. Now, what is the potential difference across this battery V? Okay, potential difference between these two terminals V. Okay, now look here. Here, see, potential will only drop when it gets the obstacle or some work is done. If there is no work done, potential will never drop. Look here. If this here potential is V, here also potential is V. Potential won't drop. But look here, when we move from positive plate to negative plate, what will happen? Potential will drop. Esto potential drop ಆಗುತ್ತೆ. ಸರ್ potential drop ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ವರ್ಕ್ ಹ್ಯಾಸ್ ಬೀನ್ ಡನ್, ಸ್ವಲ್ಪ ವರ್ಕ್ ಆಗಿರುತ್ತೆ ಅಲ್ಲಿ ಆ ಚಾರ್ಜನ್ನ ಸ್ಟೋರ್ ಮಾಡಲಿಕ್ಕೆ. ಸೊ ಪೊಟೆನ್ಷಿಯಲ್ ಡ್ರಾಪ್. ಹೌ ಮಚ್ ಇಸ್ ದ ಪೊಟೆನ್ಷಿಯಲ್ ಡ್ರಾಪ್? V1. ಸರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡ್ರಾಪ್ ಅಂತ ಹೇಳಿದ್ವಿ, ಆಗಲೇ ಡಿಸ್ಕಸ್ ಮಾಡಿದೆ ಅಲ್ವಾ? ಪಾಸಿಟಿವ್ ಪ್ಲೇಟಿಂದ ನೆಗೆಟಿವ್ ಪ್ಲೇಟ್ ಸೈಡಿಗೆ ನಾವು ಹೋಗಬೇಕಾದ್ರೆ ಪೊಟೆನ್ಷಿಯಲ್ ಏನಾಗುತ್ತೆ? ಡ್ರಾಪ್ ಆಗುತ್ತೆ. ಆಮ್ ಐ ಕ್ಲಿಯರ್ ವಿತ್ ದಿಸ್? ಓಕೆ, ದೆನ್ ವಿ ಮೂವ್ ಫ್ರಮ್ ಹಿಯರ್ ಟು ಹಿಯರ್. ವಿಲ್ ದೇರ್ ಬಿ ಎನಿ ಪೊಟೆನ್ಷಿಯಲ್ ಡ್ರಾಪ್ ಬಿಟ್ವೀನ್ ದೀಸ್ ಟು ಪಾಯಿಂಟ್ಸ್? ಆಗುತ್ತಾ? ಎಸ್ ಆಗುತ್ತೆ. ಯಾಕೆ? ಪಾಸಿಟಿವ್ ಪ್ಲೇಟಿಂದ ನೆಗೆಟಿವ್ ಪ್ಲೇಟ್ ಸೈಡ್ಗೆ ಹೋಗ್ತಾ ಇದ್ವಿ. ಆ್ಯಂಡ್ ದ್ಯಾಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡ್ರಾಪ್ ಐ ವಿಲ್ ಕಾಲ್ ಇಟ್ ಆಸ್ V2. And when we move from here to here, will there be any potential drop? Yes sir, potential drop will be there. How are you considering this potential drop? ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲಿಂದ ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ ಕಡೆಗೆ ನಾವು ಮೂವ್ ಆಗಬೇಕಾದ್ರೆ ಪೊಟೆನ್ಷಿಯಲ್ ಏನಾಗಿರುತ್ತೆ? ಡ್ರಾಪ್ ಆಗಿರುತ್ತೆ. Am I clear with this? How much is the total potential drop across these capacitors? V1, V2, V3. Am I clear with this? So we are writing next line, potential difference across circuit. Total circuital potential ಎಷ್ಟು ಡ್ರಾಪ್ ಆಗಿದೆ? potential difference across the circuit is equal to what? Potential difference ಎಷ್ಟಿದೆ? is equal to potential difference, sum of potential difference across each individual capacitors. ನೋಡಿ ಮಕ್ಕಳ, ಟೋಟಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡ್ರಾಪ್ ಎಷ್ಟಾಗಿದೆ? ಸರ್ V1 plus V2 plus V3. So let me write that. Total potential drop potential drop or potential difference, you can call it potential difference. Potential difference is equal to V1 plus V2 plus V3. Okay, now look here, I am going to construct an equivalent circuit here, and this is the equivalent circuit. We will connect the same battery here which has the potential difference V, positive terminal, negative terminal, and we will connect them to a capacitor of capacitance CS. We will say CS. Sir, CS ante yaake tagondidira? Because I am calculating equivalent capacitance in series combination. Am I clear with this concept? Okay. Look here. This capacitor consumes same charge, same amount of charge as consumed by all these combination of capacitors, and same potential difference is applied across combination of capacitors and this capacitors. This capacitance is equivalent to the capacitance offered by all of these. C1, C2, C3 series ಅಲ್ಲಿ ಎಷ್ಟು capacitance provide ಮಾಡುತ್ತೋ ಸಿ ಎಸ್ ಕೂಡ ಅಷ್ಟೇ ಕೆಪಾಸಿಟೆನ್ಸ್ನ ಪ್ರೊವೈಡ್ ಮಾಡುತ್ತೆ. ಸೊ ಅಂಡ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಈಕ್ವಿವೇಲೆಂಟ್ ಕೆಪಾಸಿಟೆನ್ಸ್. equivalent capacitance or equivalent capacitor. This is equivalent capacitor, CS. Okay. Equivalent capacitance, so capacitance antane barayada, capacitor beda. Okay, capacitance, CS is. And this is the equivalent capacitor. Now, look here. How much is the capacitance here? What is the formula? C is equal to Q by V. Okay, this circuit has got C is equal to Q by V. CS is equal to Q by V. Okay. Now, total potential drop, potential difference between in the circuit V. Here also V. So that is potential difference. It is equal to V1 plus V2 plus V3. Simple concept. Total potential ಎಷ್ಟು ಡ್ರಾಪ್ ಆಗಿದೆ, potential difference ಎಷ್ಟಿದೆ, V1 plus V2 plus V3. Simple. Okay. Now, look here. C is equal to what? Q by V. So we have V is equal to what? Q by CS. Am I clear with this? In the place of V, potential across the circuit, what can I substitute? Charge consumed by the capacitor divided by its capacitance. Equivalent capacitance in ಬರ್ದಿದ್ದೀನಿ. ಇದು ಸೇಮ್ ತಾನೆ. ಈ ಸರ್ಕ್ಯೂಟ್ ಮತ್ತು ಈ ಸರ್ಕ್ಯೂಟ್, both of them does same amount of work. What is V1? Potential drop across capacitor C1. How much is the value of V? What is the value of V? Q by C. Okay. Across capacitor, what is the charge? Q. What is the capacitance? C1. Okay. Now, V2. V2 is what? Potential drop across the capacitor C2. Okay. How much is the potential difference? That is Q by C. So how much is the charge here? Q divided by what is the capacitance? C2. Sir, ಅಲ್ಲಿ plus Q minus Q ಇದೆ, ನೀವು ಯಾಕೆ ತಗೊಳ್ತಿಲ್ಲ? I am only considering charge on the capacitance. Magnitude consider ಮಾಡ್ತಾ ಇದ್ದೀನಿ, sign consider ಮಾಡ್ತಿಲ್ಲ. Plus, okay. What is V3? Potential difference across capacitor C3. That is equal to charge on the capacitor divided by charge on the capacitor plate divided by capacitance. Now, look here. Can I take Q common? So Q common. So we are left with CS into Q is equal to Q into 1 over C1 plus 1 over C2 plus 1 over C3. Q gets cancelled. So now I get 1 over CS, that is equivalent capacitance, is equal to 1 over C1 plus 1 over C2 plus 1 over C3. Now look here. What is the relationship between equivalent capacitance and combination of capacitors in this circuit? Very simple. Reciprocal of equivalent capacitor is equal to sum of reciprocal of each individual capacitor. We will write it. Reciprocal, write with me. Reciprocal of equivalent capacitors. Equivalent capacitor is, sorry, not capacitor, capacitance. Capacitance is equal to sum of reciprocal ಹೌದಲ್ವಾ? 1 by CS ಇದೆ. reciprocal of equivalent capacitance is equal to sum. Look at sum of 1 by C1 ಅಂದ್ರೇನು? reciprocal of capacitance. Sum of reciprocal of each individual capacitance of capacitors connected. In which connection? Yes, series connection. Okay. Look here, let me conclude this. A very simple concept. we have a capacitors connected in the series combination. We connect it to a battery, and when we connect it in a series combination, the charge distributed on each capacitor is equal. So that is the first point. And across each capacitor there will be potential drop, because across each capacitors we are moving in the direction from positive plate towards negative plate. Okay, that I have explained earlier. And then what is the total potential drop across the capacitor? How much is the total potential drop? V1, V2, V3, that is equal to V. Okay, then we have constructed equivalent circuit. Okay, and CS is the equivalent capacitance. We need to find out the relationship between equivalent capacitance and combination of capacitors. This capacitor, these three capacitors provide the equal capacitance as provided by this capacitance. So V is equal to V1 plus V2 plus V3, and we have substituted respective values which is obtained here, and we have taken Q common, and we have established this relationship. And this relationship says if we connect the capacitors in series, how much is its equivalent capacitors? Just take the reciprocal of each capacitors and add them. That's it. Okay, let us study the instrument. See, we need to discuss important things and the series combination. Look here, if we have two capacitors connected in series, let me take that is C1 and C2. These are the two capacitors connected in series combination, okay, connected to a battery. I am not writing the battery here. How much is its equivalent capacitance? Reciprocal of equivalent capacitance is equal to the sum of reciprocal of each individual capacitance. Very simple. ಇಲ್ಲೊಂದು ಕೆಪಾಸಿಟರ್ ಇದೆ, ಇಲ್ಲೊಂದು ಕೆಪಾಸಿಟರ್ ಇದೆ. ಈ ಎರಡು ಕೆಪಾಸಿಟರಿಂದ ಈಕ್ವಿವೆಲೆಂಟ್ ಕೆಪಾಸಿಟರ್ ಎಷ್ಟು ಬರುತ್ತೆ? ದಟ್ ಈಸ್ 1 over CS is equal to 1 over C. Equivalent capacitance in series is equal to 1 over C1 by 1 over C2. That means 1 over C is equal to equivalent capacitance is equal to, so I will take the LCM, that becomes C1 C2 C2 plus C1. Just I have taken LCM and I have added it. Now if you take the reciprocal of it, so equivalent capacitance is equal to what? C1 C2 divided by C2 by C2 plus C1. This is the equivalent capacitance. In which case, when only two capacitors are connected. This is very simple. When only two capacitors are connected, what is its equivalent capacitance? That is product of capacitor by sum of capacitors. If I have a capacitance of 2 farad, 2 microfarad, and another capacitance of 3 microfarad, how much is the equivalent capacitance of these two? That is very simple. That is product of these two, 2 into 3 divided by sum of these two, 2 by 3 is equal to what? Is equal to 6 divided by 5 microfarad. This is very simple. Am I clear with this? We can easily calculate capacitance in this form when there are only two capacitors. That is the first thing. And next, this, let's take this note as A and take this note B. Now we will connect equal capacitors in series. These capacitors have equal capacitance, that is C, this is also C, and this is also C, and this is also C. So we will keep on continuing it. First we will calculate for 4. Okay, equivalent capacitance in series connection is equal to how much? It is equal to 1 over equivalent capacitance in series is equal to sum of reciprocal of each individual capacitance, that is 1 over C plus 1 over C plus 1 over C plus 1 over C. So that is 1 over C is equal to, look here, 1 by C, 1 by C, 1 by C, 1 by C. How many 1 by C? 4, 1 by C. So that is 4 divided by C. 1 by C plus 1 by C plus 1 by C plus 1 by C. How many 1 by C's are there? 4 1 by C's are there. That is 4 by C. So if you take the reciprocal of it, you will get CS is equal to C divided by 4. So 4 equal capacitors connect ಮಾಡಿದಾಗ capacitor divided by 4 ಆಯಿತು. ಅಕಸ್ಮಾತ್ we have a combination where we have connected n number of capacitance, n number ಎಷ್ಟು ಕೆಪಾಸಿಟನ್ಸ್ n ನಂಬರ್ ಮಾಡಿದ್ದಾರೆ. ಅವಾಗ ಏನು ಮಾಡಬೇಕು ನೋಡಿ, ಇಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಬರುತ್ತೆ, n ನಂಬರ್ ಆಫ್ ಕೆಪಾಸಿಟರ್ಸ್ ಆರ್ ಕನೆಕ್ಟೆಡ್ ಇನ್ ಸೀರೀಸ್ ಅಂತ. ಅವಾಗ ಫಾರ್ಮುಲಾ ಏನು? CS is equal to C divided by n. ಅಕಸ್ಮಾತ್ 1 microfarad ಇಂದು 100 ಕೆಪಾಸಿಟರ್ಸ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದಾರೆ, 100 ಕೆಪಾಸಿಟರ್ಸ್ ಮಾಡಿದ್ದಾರೆ. ಎಷ್ಟು 100 ಕೆಪಾಸಿಟರ್ಸ್ ಮಾಡಿದ್ದಾರೆ. ಹೌ ಮಚ್ ಇಸ್ ದ ಕೆಪಾಸಿಟನ್ಸ್? ವೆರಿ ಸಿಂಪಲ್ ಸರ್. ಸಿ ಎಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಇಂಡಿವಿಜುವಲ್ ಎಷ್ಟಿದೆ 1 ಮೈಕ್ರೋ ಫ್ಯಾರೆಡ್ ಡಿವೈಡ್ ಬೈ ಎನ್ ಎಷ್ಟು 100, ದಟ್ ಈಸ್ 1/100 ಮೈಕ್ರೋ ಫ್ಯಾರೆಡ್. ಈಕ್ವಲ್ ಕೆಪಾಸಿಟರ್ಸ್ನ ಸೀರೀಸಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿದರೆ ಏನು ಮಾಡ್ತೀರಾ? ದಟ್ ಈಸ್ ವೆರಿ ಸಿಂಪಲ್. ಕೆಪಾಸಿಟರ್ ಡಿವೈಡ್ ಬೈ ನಂಬರ್ ಆಫ್ ಕೆಪಾಸಿಟರ್ಸ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್, this is an important conclusion. I want you to understand this. Look here children, I will take three capacitors. One capacitor I will take 2 microfarad, and another capacitor 5 microfarad, and another capacitor 3 microfarad. Okay, and this is connected to a battery and they will get charged. Now what is the total capacitance provided by combination of these capacitors? They are in series, so 1 over Cs, that is 1 over equivalent capacitance in series, is equal to 1 over 2 microfarad plus 1 over, I will just put on the values, 1/2, 1/5, capacitance is to 5 microfarad, so that is 1/5 microfarad plus 1/3 microfarad. So how much do I get? How much do I get? Just calculate. So 1/2 is 0.5. 1/5 is how much? 0.2 plus this is 1/3, that is 0.33. Okay, 1 over Cs is equal to, how much is this? 0. So you take the reciprocal of this. Reciprocal of this becomes Cs is equal to 1 over 1.03, which will be equal to some 0.97 microfarad. Look here children, so we use 2 microfarad, 5 microfarad, 3 microfarad, and what is the total capacitance suffered by it? 0.97. That means in series combination the equivalent capacitance will be less than the least capacitance. 2 microfarad, 3 microfarad, 5 microfarad ಹಾಕಿದ್ದೀವಿ. ಸೀರೀಸಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ ಅದ್ರದ್ದು ಓವರಾಲ್ ಈಕ್ವಿವೆಲೆಂಟ್ ಕೆಪಾಸಿಟನ್ಸ್ ಎಷ್ಟು ಬರುತ್ತೆ? 2 ಮೈಕ್ರೋಫ್ಯಾರಡ್ಗಿಂತ ಎಕ್ಸಾಕ್ಟಾಗಿ ಕಮ್ಮಿ ಬರಲೇಬೇಕು. ಆಮೇಲೆ ಕ್ಲಿಯರ್ ವಿತ್ ದಿಸ್? ಸೀರೀಸ್ ಕನೆಕ್ಷನಲ್ಲಿ ನೀವು ಕೆಪಾಸಿಟರ್ಸ್ನ ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೀರಾ, ಈಕ್ವಿವೆಲೆಂಟ್ ಕೆಪಾಸಿಟನ್ಸ್ ಎಷ್ಟು ಬರಬೇಕು? ಲೀಸ್ಟ್ ಕೆಪಾಸಿಟನ್ಸ್ ಎಷ್ಟಿರುತ್ತೋ ಅದಕ್ಕಿಂತ ಕಮ್ಮಿ ಬರಬೇಕು. ಸಿ, ದಟ್ಸ್ ಅಬೌಟ್ ಕೆಪಾಸಿಟರ್ಸ್ ಇನ್ ಸೀರೀಸ್. ಥ್ಯಾಂಕ್ ಯು.